Welcome to EMILAC chemistry tutorial. Alright, before us is this question, and in this video we'll be solving 10 questions on mass percentage composition, and here is number 1. Now this is, and it says calculate the percentage composition by mass of each element in sodium triisobicarbonate 5. Alright, first of all, what do we do? First of all, let us look for the molecular mass of this compound. Now this is sodium triisobicarbonate 5. Now first and first, we just need to split it. Now you can see that sodium is having two atoms here. So here you have 2 sodium, then plus carbon is 1, plus oxygen is 3. So you have 3 oxygen. So here you have 2 times 23 plus 12, now plus 3 times 16, and this will give us, should be 46 plus 12 plus 48, and in total now, punching our calculator, this should give us 106. Okay, now to find the percentage composition by mass of each element, now it implies that we take nitrogen first. Now take note that nitrogen has two atoms here. So here you have 2 sodium rather, over 106, now times 100%. Now the second one, which is carbon has only 1 atom, 106 times 100%. And the third one, which is oxygen has 3 atoms, so that will be 3 times, okay, let me just put it as 48. Then here, let's just make it 46. Now, if we are to punch our calculator here, approximately, here we have, for the first one is 43.4%. Now, the second one, we have 11.3%, and the last one is 45.3%. Alright, now this is the percentage by mass composition of each of the elements in this compound. Alright, now let's move to number 2. Now for number 2 here, and it says calculate the percentage composition by mass of each of the elements, and this is calcium triisobicarbonate 5. Okay, now first of all, we will need to find the molecular mass of this compound. And how do we do that? Let us now split this compound. Here we have calcium, now plus carbon, plus 3 atoms of oxygen. Now we know that the atomic mass of calcium is 40, now plus 12, plus, sorry, that of carbon is 12, and for oxygen here is 16, and 3 times 16 will give us 48, and when we add all this together, it gives us 100 grams. Okay, alright, now for us to get the percentage composition of each element here, we will now take it one by one. Calcium, we know it is 40 for calcium. You have 40 over 100 times 100, right? Then carbon, which is 12 over 100 times 100. And oxygen, which is 3, that will be 48 over 100 times 100. I'm sure this is very simple. Just eliminate all this, the 100, and this will give us 40%. It will be 12% and 48%. Alright, this is the second one. Now let's move to the third one, which is a bit difficult than this. Alright, okay. Now for number 3 here, it says a sample of brass contains 60% copper and 40% zinc. Now, what mass of brass would contain 100 grams of copper? Okay, to this end, now that is the normal brass now has 60% of copper and 40% of zinc. Now the question now is, now what mass of brass will contain 100 gram of copper? Now ordinarily for the normal brass, it is 60% of copper, which is 60 all over 100. Okay, now let's now say that the mass that will produce 100 gram of copper, let us say it is now M. Okay, now we have to multiply it by the percentage of copper that is being present in the normal brass content. Now that will now give us 100 gram of copper. Okay, now to this end, you can now make M the subject of a formula. But in this, to this, 60 divided by 100 here, we can have it as 6.012. Let's cancel out these 2 and bring a decimal 12. So then you have M times M will give us what? 100 gram. So dividing both sides by 0.6. So our M, by punching our calculator here, we should have 166.6666, approximately 7 gram. So the mass of brass that will give 100 gram of copper is 166.7 gram. Now let's move to number 4. Now question 4 says that the complete combustion of 1 centimeter cube of hydrocarbon requires 5 centimeter cube of oxygen. Now identify the compound and write the balanced equation for the reaction, given that 3 centimeter cube of carbon dioxide is produced. Now first of all, we will need to recall the general formula for the combustion of hydrocarbon, which is given as here we have X plus Y over 4, then that of oxygen, then which will give us X now plus Y over 2. Right. Okay, now this is the general formula. Now take notes that according to Gelizat law, that the number of moles here is the same thing with that of the volume. Okay, now if that's true for the case, now we are told here that it requires 5 centimeter cube of what? Oxygen. So it implies here that this number of mole here is equal to what? 5 centimeter cube. Okay, all right. And here also we are told that 1 centimeter cube of hydrocarbon. Now this is the 1 centimeter cube. I mean, this is a mole of the hydrocarbon, which is also equivalent to what? 1 centimeter cube. All right. To this effect, now we can actually bid forth an equation here by saying X plus Y over 4 equals 5. Yeah, because the amount of mole here is the same thing as the volume represented. Okay, so and if that be the case here, then we can also imply that from here now we can now probably make xy the sort of the formula. In this case here we have 4x plus y then equals 20. Okay, all right. And if that be the case also, we are also told that given that 3 centimeter cube of carbon dioxide is produced here, so it implies that if this is the number of mole and 3 centimeter cube is produced, which implies that x is equals to what? The volume, which is what? 3. So we can see here that x equals to 3 centimeter cube. Now in that case, now let us plug in the value of 3 here. We have 4 times 3 plus y equals 20, and this will give us the y. Take note, this one now will give us 12, you know, and when we take 12 over to the right hand side, become negative. We have 20 minus 12, then y here will give us 8. Okay, now let us now plug in the values of y and x in the given equation. Now take note that the whole of this actually is 5 already. So here we have that c 3, h 8 because y is 8. Then the whole of this already is 5. We have 5. Then we give us here with 3. Now plus y here is 2. So 2 divided by 4. Sorry, 8 divided by 2 here will give us what? 4. Okay, so we are told to identify the compound. Now this is the compound, which is propane. Okay, and the balance equation to this regard, now it is balanced. Carbon is 3 here, carbon is 3 here, hydrogen is 8, 4 times 2 is 8, then oxygen is 10. Here we have 6 plus 4 is 10. All right, now let's move to number 5. Now for number 5 here, we are told here that an organic compound consists of carbon, hydrogen, and oxygen. On combustion, now a 9.5 gram sample of the compound produces 18.2 gram and 11.2 gram of carbon dioxide and water vapor respectively. Now if 1.5 gram of the sample occupies a volume of 750 centimeter cube when vaporized at 28 degrees centigrade and 108.4 kilopascal. Now determine the mass composition of each element. Now B, the molar mass of the compound. Alright, now let us note this, that when 9.5 gram of the said organic compound was heated or probably undergo combustion, now 18.2 gram of carbon dioxide was produced. So 18.2 gram of carbon dioxide. Now let us find the molar mass of carbon dioxide. In this case, now this is 12 plus 2 times 16, which is the atomic number of each of the element here. So here we have, this is 12 plus 32, and this should give us 44, right? Okay, and that of water vapor, which is water, that is 11.2 gram of water, or which is vapor in terms of the gas. So here we have hydrogen, which is 1 times 2, we have 2, plus oxygen 16, and this will give us 18. All right, now you can see that these two compounds contains oxygen and oxygen. Now first of all, let us find the composition of carbon here, and also find the composition of hydrogen here. Now for carbon here, since it is one atom here, you have 12 all over. Now what is the total? That'll be 44 now times 18.2. Now this one is for carbon. Now for for hydrogen, we have here we have 2, yeah, because it's having 2 atoms, then over the molar mass, then times the mass, that will be 11.2. So now if we tend to punch our calculator, so in this case for carbon here, we have 4.96, this is approximately 5.0. Then for hydrogen, now this should be about 1.24, then just approximately 1.2. Okay, Alright, now to this effect now that we've gotten the percentage composition of carbon and the percentage composition of hydrogen, now let us get that of what? Oxygen. And how do you do that? Now take note that the total mass here for the compound is 9.5, right? Now since we've gotten carbon and hydrogen, now let us add these two. By adding this, we have a 5.0 plus 1.2, so give us 6.2. Okay, so for that of oxygen here, we now have 9.5 then minus 6.2, and this should give us, that will be 3.3. okay, now this is for carbon, hydrogen and oxygen. All right, take notes. Now we are now told to find the molar mass of the compound. Now we will make use of the general gas equation, or the ideal gas equation rather, which is PV equals nRT, where P is the pressure, V is the volume, N is the number of mole. This is the molar gas constant, and the temperature. Now we are giving pressure to be, pressure is given as 108.4 kilopascal. Now our volume is given in centimeter cube. Now if I were to divide it by 1000 to give us in decimeter, you have 0.750 centimeter cube. Then that of, here we have the temperature. Here you have 228 now plus 273. Now this should give us 301 Kelvin. Alright, now let us now plug in this parameter to get the number of what? The value of mole. So here we have 108.4 times the volume 0.750, now equals the number of mole, now times our molar gas constant is 8.314, is given here already, then times 301, which is the temperature. So making N the subject of relation, here we have 108.4 times 0.750, then over 8.314 times 301. Now punching our calculator here, we get to have 0.0325 moles, right? Now, and take note that the number of mole equals to the mass over the molar mass, and we are told to find the molar mass. Now take note that the mass is already given as 1.5. So if we have to make the molar mass the subject of relation here, we have that the molar mass will give us mass over the number of mole, and which is 1.5 over 0.0325. Now punching our calculator, okay, we get to have 46.2, then approximately 46.0. okay, now that is the molar mass of the said compound. That will be gram per mole. Alright, now this is number 5 question. Now let's move to number 6 question. Now for number 6 here, you can see we're having that zinc and magnesium each react with hydrochloric acid to make chloride salt of the respective metal as well as hydrogen gas. Now a 10.00 gram mixture of zinc and magnesium produces 0.517 gram of hydrogen gas upon being mixed with an excess hydrochloric acid. Now determine the percentage of magnesium by mass in the original mixture. Alright, first of all, let us write out the equation here. We are told that zinc now plus magnesium. Now a mixture of this is mixed with hydrochloric acid. Now to produce their respective chloride salt. So here we have zinc chloride 2. Then we also have magnesium chloride 2 and hydrogen gas. Alright, let us see if this equation is balanced. Now zinc is 1, magnesium is 1, magnesium is 1. Now chlorine here is 2 and 2, making 4. So let us put 4 here. Then hydrogen here is 4, here is 2. Okay. Alright, now from this equation now we can see that 2 moles of hydrogen gas is what produced. Okay, which implies that 0.517 gram of hydrogen gas is equivalent to 2 moles of hydrogen gas. Okay, now how many gram of hydrogen gas will produce 1 mole? So let us say x gram of hydrogen gas is equivalent to 1 mole of hydrogen gas. Okay, and if we are to make x the sort of formula, then we have that x gram will be 0.5171 all over 2, and this will give us a 0. Here you have 2, remainder 1, here we have 5, remainder 1, here you have 8, here remainder 1, here we have what, 5. So moles of, gram of what, oxygen gas. So we have this particular gram to produce 1 mole of hydrogen gas. Alright, to this effect now, or to this point now, we can, it implies also that 24 gram, now looking at this equation, that is the atomic mass of magnesium is 1, and you can see it's just 1 mole. Now 24 gram of magnesium gave birth to 2 moles, right? That will be 2 moles of, and from here you can see it is 24 gram to give us what, 2 moles of hydrogen gas. Okay, now what gram of magnesium will give 0.25, let us say 9 approximately gram of. Okay, so punching our calculator, here you have that x of magnesium, x gram of magnesium will now be 24 times 0.259 all over 2, and this will give us 12 times 0.259. Okay, because 2 here 1, 2 in 24 is 12. Alright, punching our calculator here. So here we have 3.108 gram of magnesium. So this is the mass present. So we are told to find the percentage by mass. So percentage by mass of magnesium in the mixture will now be 3.108 over the total mixture is 10. Now times 100. 0 will cancel 0 here. Then since we have 10, we can now change out the decimal here. So we have what, 31.08% of magnesium, alright, present in the mixture. Alright, let us now move to number 7. Now for number 7 here, the question is, when a 14.2 gram sample of mercury 2 oxide is decomposed into its element by heating. Now 13.2 gram of mercury is obtained. what is the percentage composition of this compound. Now, writing up the compound here, this is mercury 2 oxide. Now, when decomposed, it gives mercury and oxygen gas. Okay, and to this end here, we can say if this is 2, then here we have 2. Okay, all right. Now, and we are told that 14.2 is decomposed into. So, if here you have 14.2 gram, and here we are given that this is 13.2 gram, definitely what we will have here to be, so here I have 1.0 gram. Okay, to this end, for that of what is the percentage composition of the compound, for mercury here, now since we've been given the mass already, so here you have 13.2 over 14.2 times 100%, and that of oxygen will now be 1.0 over 14.2 times 100%. And by punching our calculator here, now this will give us approximately 93%, and this one should give us 7%. Alright, now let us move to question number 8. For number 8 here, now we have it as an adult bone weigh about 11 kg, and 50% of this mass is calcium phosphate, and this is the formula. Now, what is the mass of phosphorus in the bones of an average adult? Okay, now to this end, now we are told that 11 kg is the weight of the human bone, and 50% of this, 50% of 11 kg is calcium phosphate. Now let us now bring out the 50% of 11 kg, that is the mass of calcium phosphate. So here we have that 50%, 50 over 100 times 11. Now this will give us 550 over 100, and this will give us, when we cancel this 2 1 2, so we have 5.5 kilogram. So, and in gram here we have 5,500 gram. Okay, so the mass of calcium phosphate equals to 5,500. Now let us now bring out the mass of the molar mass rather of calcium phosphate here. Now calcium 3 has 3 atoms. Now in this case here, phosphorus also is having 2, and oxygen here will be having 8, because 4 times 2. So here we have 3 calcium plus then 2 into phosphorus plus 4 times oxygen. Let me use a square bracket. So, and calcium is 40, that will be 3 times 40, then plus 2. Now phosphorus is 31, then plus 4 times 16, that will be 4 times 16, that should be 'okay. So here we have 120 now plus 4, that will be 64. I've been trying to recollect the product of this. That will be 64, and when we multiply these two here, that will be 2 times that will be 62 now plus 8, and when we add all this together, this one should give us 310. Okay, gram per mole. All right. Okay. So to this end here now, phosphorus here is 31 times 2, that will be 62. Okay, so to this end here we have 62 over the molar mass times the mass percentage. Okay, let us eliminate 0 here and punching our calculator here. So the mass of phosphorus in this here is given as 1100 gram. Okay, all right, let us now move to number 9. All right, for number 9, a 10-gram sample of silicon carbide is found to contain 3.0 gram of carbon. What is the percentage composition of silicon carbide? All right, so far since we've been solving questions relating to mass percentage composition, you can pause this video and solve this to know your capacity. Okay, all right, let us now continue with this. This is 10 gram. Okay, now if the total composition is 10 gram and carbon is 3, so if carbon equals to 3, then definitely silicon will definitely be 7.0. Okay, all right, for us to find the composition here, so for carbon we have 3 all over 10 times 100, and this will give us 30%. And silicon, here we have 7 over 10 times 100%. Cancel one of the 0, we have what? 70%. Okay, right, let us now move to the last question. Now for the last one here, we have the hemoglobin contains 0.33% by mass iron. Now there are 2 iron atoms in 1 molecule of hemoglobin. Now what is the relative molecular mass of hemoglobin? Now in this case, now take note that 0.33% by mass is that of what? Iron. Okay, now we are told that 1 molecule, let us assume 1 molecule, 1 mole of H, which is represented by hemoglobin, contains 2 atoms of what? Iron, which implies 2 times what? 56, and which is the atomic number, that is the approximate atomic number of iron, and this should give us 211. Okay, this is the mass. Okay, all right, and to this effect here now, 0.33% of what? Let us say that is the mass of the hemoglobin that will give us 112. Okay, take note that it is 0.33 by mass of iron. So now we don't know, this X here represents the relative molecular mass of hemoglobin. So to this effect here, this is simply saying 0.33 all over 100 times X, then equals 112. To this we can multiply, that will be 0.33x. now multiply, okay, let me say by 100 equals 112. Now we can now cross multiply, we have 0.33x equals 11200, because 100 times 102 give us 11,200. Now let's divide both sides by 0.33. This we eliminate. Now we are left with that x equals, now punching our calculator here, so here we have 33939.39, which is 33939.5. 4 approximately. Okay, and that is the relative molecular mass of hemoglobin. Now we've come to the end of this video. If you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in chemistry. Thank you and God bless you.